Welcome to the third video lecture on fluid dynamics numericals. The first video lecture we have seen the numericals based on Bernoulli's equation and the numericals based on total energy. In the second video lecture we have seen the numericals based on Venturi meter and orifice meter. Now in this today's third video lecture we'll be seeing the numericals based on a Pitot tube. Pitot tube. Pitot tube is a device which is used to find the velocity of flowing fluid at any point in a pipe or channel. The velocity is given by the relation V is equal to Cv into under root 2gh, where Cv is equal to coefficient of velocity of Pitot tube, h is equal to rise of liquid in the tube above the free surface of liquid. Now, whenever this Pitot tube is connected to the differential manometer, then the h can be calculated by the formula h is equal to x into bracket Sg upon S0 minus 1, where x is equal to the differential manometer reading, Ag is equal to manometric fluid's specific gravity, S0 is the specific gravity of the fluid which is flowing through the pipe. A Pitot tube. Pitot tube is a device which is used for the measuring the velocity of flow at any point in a pipe or a channel. It is based on the principle that if the velocity of flow at a point becomes zero, the pressure there is increased due to the conversion of kinetic energy into pressure energy. In its simplest form, the Pitot tube consists of a glass tube bent at right angles as shown in figure. The lower end, which is bent at 90 degrees, is directed in the upstream as shown in figure. The liquid rises up in the tube due to the conversion of kinetic energy into pressure energy. The velocity is determined by by measuring the rise of the liquid in the tube. So the two depths we are getting they are as like this. H is equal to depth of tube in the liquid, and small h is equal to rise of liquid in the tube above the free surface. Now these are the some of the arrangements by which we can connect this to the Pitot tube. Now let us see these arrangements one by one. Now the first arrangement which is shown is the Pitot tube along with the vertical piezometer. Now in this arrangement, a Pitot tube is kept in the pipe, or it is inserted in the pipe, and we are inserting a piezometer tube at another point. Now what will happen? Through this piezometer some water will be rising over here, and through this Pitot tube the water level will be rising in this Pitot tube too. So whatever is the difference of this rising water level, this is the h we are getting, and we need to directly substitute this value of h in the formula V is equal to Cv into under root 2gh. Similarly, now this Pitot tube is connected to the piezometer tube. So this is the another arrangement. Again in this we are calculating the difference between these two water levels, and we are substituting these the difference of these two water levels in the formula Cv into under root 2gh. Now in this next two arrangements we can see that here the Pitot tube is connected to a differential U-tube manometer. Now in this the differential U-tube reading is calculated, which is x, and it is substituted in the formula of h is equal to x into bracket Sg upon S0 minus 1. Now in the last arrangement here we can see the Pitot static tube. Now Pitot static tube consists of two circular concentric tubes, one inside the other with some annular space in between them as shown in figure. The outlet of these tubes are connected to the differential manometer, where the difference of the pressure head h is measured by knowing the difference of the levels of manometer, say x. Therefore h is equal to x into Sg upon S0 minus 1. So in short, whenever this arrangement is given, that is of differential manometer, we need to use this formula. Whenever this arrangement is not there, that is of the differential manometer, directly we can calculate the h, or directly we are getting the value of h. So how this Pitot static tube works? Now Pitot static tube is kept like this in the pipe, then water at one end is entering through this pipe and it is moving like this, and it is pushing this manometric liquid, and the second end or the another orifice is provided perpendicular to this direction, that is in this direction, and in this direction. The water is flowing through this two directions and entering over here, and it is going like this, and it is pushing this liquid over here. Now we have to measure this pressure head difference, and we have to calculate this x, and we have to measure this x, and we have to calculate h with the help of this x. So this is the working of the pitot static tube. Now the numericals. The first numerical is like this: the velocity of flow of an oil through a pipe. We need to find that velocity when the difference of mercury level in the differential manometer connected to the two tappings of the pitot tube is 100 mm. Take the coefficient of pitot tube is equal to 0.98 and specific gravity of oil is equal to 0.8. So what is the data being given to us in this numerical? We need to find the velocity of flow of an oil which is flowing through the pipe when the difference of mercury level in the differential U-tube manometer, means pitot tube is connected to differential U-tube manometer. So we need to calculate H with the help of the formula, that is H is equal to X into Sg upon S0 minus 1. So we need this reading X. So it is given also in this numerical. So when the difference of mercury level in the differential manometer connected to the two typings of the pitot tube is 100 mm. So the value of X is 100 mm for this numerical. Take the coefficient of pitot tube, that is CV value is being given to us as 0.98, and specific gravity of oil which is flowing through this pipe is 0.8. So substituting all these values, we will be getting this, the velocity of flow. That is, first we will be calculating the value of difference of pressure head, that is H is equal to X into Sg upon S0 minus 1. So the value of X is 0.1 meter, which is over here. So we'll be substituting over here. The Hg value is the 13.6, which is the specific gravity of mercury, and So the value is 0.8, which is the value of the liquid which is flowing through the pipe, that is 0.8. Now we will be calculating the H is equal to 1.6 meter of oil. Substituting this in the equation of Cv into under root 2gh, we get the value of the velocity as 5.49 meter per second. The next numerical: a submarine moves horizontally in a sea and has its axis 15 meter below the surface of water. A pitot tube properly placed just in front of the submarine along its axis is connected to the two limbs of U-tube containing mercury. The difference of mercury level is found to be 170 mm. Find the speed of the submarine, knowing that the specific gravity of mercury is 13.6 and that of sea is 1.026 with respect to fresh water. Now just see what is being given to us in this numericals. So a submarine is moving horizontally in sea with its axis 15 meter below. So what is this 15 meter? See, this 15 meter is this value. The submarine is moving like this, and this is the capital H, and this capital H is not needed in the calculation of the velocity, but still it is being given to us below the surface of water. A pitot tube properly placed just in front of submarine and along its axis is connected to the two limbs of U-tube containing mercury. So this pitot tube is connected to U-tube manometer which is containing mercury. Okay, the difference of mercury level is found out to be 170 mm. That is what is being given to us. The value of X is being given to us. Find the speed. We need to calculate the velocity such that the specific gravity of mercury is being given to us, that is 13.6, and that of sea water is also being given to us, that is 1.026. So we'll be calculating first H. H is equal to X into bracket Sg upon S0 minus 1. So where this X is equal to 0.17 meter into Sg, that is mercury, this specific gravity of mercury, and S0, that is the specific gravity of the sea water, that is 1.026 minus 1, which is giving us the value of 2.0834 meters. Substituting this value in the formula of calculating the velocity, that is V is equal to Cv into under root 2gh. So in this numerical, Cv is not being given to us, therefore we are using the formula V is equal to under root 2gh, which is equal to under root 2 into 9.81 into 2.0834, which is equal to 6.393 meters per second. Now the next numerical. Now in this numerical, we are using the Pitot static tube. So a Pitot static tube is placed in the center of 300 mm pipeline, has one orifice pointing upstream and other perpendicular to it. The mean velocity in the pipe is 0.8 of the central velocity. Find the discharge through the pipe if the pressure difference between the two orifices is 60 mm of water. Take the coefficient of tube as 0.98. So what is being given to us? Let us see. A bit of static tube is given to us, and which is placed in the center of the pipeline. The mean velocity, the relation between the mean velocity and central velocity is being given to us. Why this relation is being given to us? Because we are placing this Pitot tube at the center of the pipe, and whenever we are placing this at the center of the pipe, so we'll be getting the central velocity. But whenever we need to calculate discharge, we'll be needing the mean velocity. Therefore the relation between mean velocity and the central velocity is being given to us. That is, mean velocity is equal to 0.8 times the central velocity. So also the pressure difference between two orifices is also being given to us. That is, x is equal to 60 mm of water, and cv is also being given to us. So by this we can calculate this. We have calculated the central velocity only, and afterwards we can calculate discharge by the equation q is equal to a into v. So diameter is being given to us, h 60 mm of water, which is equal to 0.06 meter of water. cv is also being known to us, and v is equal to 0.8 into central velocity. So just understand what is the meaning of mean velocity. As we know that in a pipe near the walls, the velocity is zero due to boundary layer condition, and the velocity goes on increasing as we are moving away from the boundary walls or the wall surface of the wall, and it is maximum at the center. So there is velocity variation over here. So whatever is this velocity variation, we need to consider this, and we need to calculate a mean of this whenever we need to calculate the discharge. And in this numerical, the relation between the mean velocity and the central velocity is being given to us. So the central velocity is found out by the equation cv is equal to v is equal to cv into under root 2gh, which is equal to 0.98 into 2 into 9.81 into 6, which is equal to this, and we will be multiplying this by 0.80. So we'll be getting the mean velocity, and after getting this mean velocity we can calculate the discharge by q is equal to area into velocity. That is, discharge is equal to area into mean velocity. Then just take the area of this, that is pi by 4 into 0.3 square multiplied by 1.063 multiplied by 0.8 will be giving us the discharge value. So thank you very much.